Hello and welcome to another episode of the Slackware ARM vlog. I'm Stuart Winter, the platform architect for Slackware on the ARM platform, and I've been doing this for almost 22 years at this point. And in this vlog, really it's all about how we develop Slackware on the ARM platform. It's like a mixture of a workshop and a chat with my co-developer Brent, and really whatever else comes up from the community that we deal with. So it's really about behind the scenes of developing one of the oldest active open source projects in the world. This year is going to be Slackware ARM's 22nd birthday, and not sure what we'll do about that. Maybe I'll bake a cake. Probably not actually, but I don't know. We'll do something. Right, but in this episode, CS Chen on Fostodon had asked me why the kernel package in Slackware ARM64 was almost a gigabyte in size compared to the x86 64 package, which was about just shy of 60 megs. And the reason for that was quite simple. It's because I hadn't removed the debug information from the kernel modules. So I've subsequently done that, and the kernel package is now about the same size. I think it's just about 60 megs. So that's great because it means that the boot process is significantly faster because it doesn't have to, because the bootloader doesn't have to load about 300 megs off an SD card. It now loads about 60. So that significantly improved the boot speed there. And also when you upgrade the kernel package, it's improved the speed of the upgrade as well, because the if you look at the, oh, that's pepper, isn't it? Where's, oh, that's honey there. Yeah, if you look at, say, if you look at the package setup script, kernel ARM v8, you'll see that so this is the post install script for the Slackware kernel package on ARM64. And you'll see that one of the things that the post-installation script does in Slackware ARM64 is that it rebuilds the OS initrd, or the operating system initial RAM disk, or the initrd as it's most commonly called in x86. It's really about reincorporating the firmware actually, but also then you can change your, if you want to customize the initial RAM disk, this automatically reincorporates any local customization. So we've been doing this for quite some time, at least 3 or 4 years at this point in Slackware ARM. But this also happens in x86 now, but it's implemented in a different way. Anyway, it's faster because, as you can see, we rebuild the initial RAM disk, and obviously repacking 60 megs versus 300 takes less time. So there's two major improvements there. It's the boot time has reduced, and so has the package upgrade time as well. Now, in the back of my mind, I've always wondered whether we could compress the kernel as well. Now, if you look, this is honey, so this is the master build machine, and you'll see that the image, this is the kernel, so this is the Linux kernel here. This is a symlink to it here, so it makes it easy to identify which kernel you have actually installed on the system, at least from looking at the file system anyway. Okay, so now you can see here that the kernel here is 11 megabytes in size. However, if we look at Pepper, which is a Rock Pro 64, you'll see the kernel is 33 megabytes in size. Yes, it's a different version of the kernel, but that's not the point. The point is that that's because this is an uncompressed Linux kernel, whereas if we look at here, you'll see that this is a gzip-compressed kernel file. So with the comment about the size of the kernel package, I thought, let me revisit this, because when I first ported Slackware to the ARM64 or ARM64 platform, you couldn't, I don't know what the problem actually was, or where the limitation was. I'm guessing it was in the bootloader, but I'm not actually sure, because even on 32-bit Slackware, or rather on 32-bit ARM, U-boot, which is the bootloader we principally use, just because it's basically the industry standard on ARM. Even 32-bit, the U-boot has been able to boot a gzip compressed kernel forever. I mean, working not forever, but for years and years and years. So even in 32-bit ARM world, let's just have a look here. So this is a, oh, we don't have that on here. That must have been an addition. Okay. So you'll see here, Z image, right? So this is Slackware version. So this is Slackware 15.0 and it's ARM 32. So it's ARM v7. So it's 32-bit ARM. You can see here that we have a Z image. So that denotes that it's a gzip compressed kernel image. And, yeah, I mean, we've been doing this for years and years and years already. So U-boot itself has been able to support gzip compressed kernel images. So I don't know why it didn't work on ARM64 or AArch64. Don't really understand that. But I remember looking when I first started the ARM port for ARM64. Actually, I'll tell you what. When did we start that? When did we start building it? Welcome to, oh, here we go. Look, so this is the changelog. 2020, December 28th, 2020. So just after Christmas in 2020, I started working on the Slackware ARM 64, AArch64. Crikey. Back then, the kernel had to be uncompressed. But again, yeah, so it got me thinking, with the size of the kernel package, I thought, is that still true? Can't we have a compressed kernel? Like, does it really not work? So I thought, I'll just try it out. So on Honey, I decided to just bite the bullet, and because I have it on Honey, it's really easy. So this is the master build machine, and it's a Honeycomb LX2. So this is the one I use for building pretty much everything in the project. And it's super easy on the Honeycomb LX2 because I can test things really easily by using the Slackware installer. So I can actually just write the Slackware installer to the SD card that's in this machine, reboot it. In the firmware, I can just go in and select to boot from SD card, boot the Slackware installer from the SD card, and test it without destroying the operating system that's on the hard drive or the SSD. So it's super easy. So I just rebooted the Slackware installer, compressed the image in the boot directory, and then rebooted it to see if it worked, and it did. So that's why so now on the actual boot partition on this machine, I have a gzip compressed kernel image. So it's been reduced from 33 megs to 11. So now the thing is, I've got it already working on the Honeycomb LX2, and that uses grub to boot, and it works. So what I haven't yet done is tried that on Pepper. So Pepper is the Rock Pro 64, and we use U-boot on here. So what I'm going to do, I'm going to compress the kernel image like this. It doesn't matter which version of the kernel it is. And we're using 6.12 on the Honeycomb LX2. You can see that we're using 6.12.8, but that doesn't matter. So we've compressed that, but you can see that gzip's appended the .gz suffix there. So what I'm going to do is just rename that like that. Okay, so there we go. So I've renamed it back to remove the .gz suffix, because the bootloader config refers to the name as zimage ARM v8, which then points to this. So that broke the symlink basically. So I just had to rename it. Is it here? Yeah, actually. So we can see here. Where is it? Is that? Oh, there it is. Yeah, there. So yeah, there's my Linux kernel there. So this is the static U-boot config here. So image ARM v8. Okay, so I've compressed that, back down to 11 megs. So now, where am I? TTY. So I'm logged in over the serial console here, TTYS2. I'm just going to test it and see if it works. So I'm going to reboot the machine now, the Rock Pro 64, and hope that it boots the kernel. If it doesn't, then oh well. I'll just network boot it and recover it, and give that up as a failed experiment. But hopefully we can boot the gzip-compressed kernel here. Let's see how we do. Okay, just let that time out. Okay, so it's loading the initial RAM disk. Oh yeah, this is the larger sized initial RAM disk. This is the version before I what do you call it? Oh, is it working? Yeah, perfect. Oh no. Oh, it booted the kernel though. Damn. Okay. But is that because of something else? No, it can't be, because I've only just booted it actually. So it should boot. Okay. But it can't. Oh wait, is it because did I add to... It should. Okay. So maybe that doesn't work. Well, what I'm going to do here, so this is the Raspberry Pi. Exit. So the Raspberry Pi, I've just finished reinstalling it because it didn't have an OS on it. So what I'm going to do here, let's have a look. So let's try it on the Raspberry Pi. And here goes. So here's our 33 megs zip-9v image. So we'll compress it on the Raspberry Pi and see if that boots it. Not sure why the... Okay, but yeah, we'll see how it goes on here first. I was thinking this was going to be a short video. Right. Okay, so we've got our... rename that back. Okay, so this is the fresh install. It's got fresh everything. So got our init RD here. That's okay. So let's see how that goes. If it doesn't work on the Raspberry Pi, then I'm not going to retry it on the Rock Pro 64 because I'm not sure why that wouldn't work. I mean, I can debug this on the... If it works on here, I might just try quickly debugging it on the Rock Pro 64. So all this stuff here, by the way, if you guys see this on your Raspberry Pi, this is okay. You can just... Ah, yeah, I didn't like it. Okay. Damn. That is a shame. That is an actual shame because... Can I boot... Does the Raspberry Pi have a DH? Yeah, it does. So, yeah, that's a shame. That is an actual shame that it doesn't like a compressed kernel. Because it works with grub. Well, I've tried it. That is a shame. Okay, so what I'm going to do is I'm going to because I want my Raspberry Pi to kind of work. So I'm just going to reboot. I'm going to network boot it, kernels, and fix it. I mean, I could just remove the SD card out of the machine, but that just actually involves physically doing stuff. I don't really want to do that. Is it? Where is it? Is it ISO Linux? I think it is. Oh no, it's installer, of course. Install TFTP. How to use? There it is. So, okay, yeah. Okay, here we are. Raspberry Pi. TF. Is that the? Yeah. Let's paste that in there. Oh. Okay, I forgot about that. TFT. Ah. Okay. There we go. That is a shame that that doesn't work. Makes me wonder though. TB0x1. TFTP/DCM 2711 B. Okay, source. Oh yeah, 0x1. So here I've just requested, where has it gone? DH there requests an IP over DHCP. What's the next thing? Then this is loading a script, a U-boot script, which contains a bunch of U-boot commands to save me typing them manually. And then this source just actually executes that script. So hopefully that will, what will that do? That will boot the Slackware installer. Yeah. So we're now booting the Slackware installer over the network onto the Raspberry Pi. And what I'm going to do is uncompress the kernel again. And then boot it back into the OS. So then I have a working, but so yeah, okay. I'm kind of disappointed, I have to say. I'm a little bit disappointed. I've got some idea of what I'm going to do next though, in a minute, just to figure something out, just in case there's one extra option here. Oh, was it SDA2? I forgot what it is now. Oh, it's this one, isn't it? It's this one, yeah. Mount /Q. So what I'm doing, this is the, this is, this here is the /boot partition, but it's on the SD card. So this is this one here, MMC Bluck 0P1. This is the Raspberry Pi. Oh, this is a FAT32 partition with the Raspberry Pi native bootloader, proprietary stuff on it. And this is /boot, which is part of the OS, but I've just mounted it to /Q because that's my favorite mount temporary directory because it's on the top of the keyboard. Right, so here's our, there it is, where is it? So we need to g-unzip, or rather, yeah, g-unzip this. And it's going to complain because, oh look, there's no suffix. I think if we can just do -dc image like that. Yeah, there we go. And then we just rename that like that. Okay, there we go. Oops. Okay, so now we have our 33 megs sync. Let's reboot it. Okay, so I've uncompressed the kernel again, and hopefully it should boot now. Still don't. Yeah. I mean, this version of the U-boot bootloader is a newer version than the version on the Raspberry, rather on the Rock Pro 64. Oh, sorry, hold on. Yikes! Oh, there we go. It scrolled off the screen. Yeah, so there we go. You can see it's booting now. Okay, cool. So we have a working OS again. Okay, cool. So there's my, there we go. There's my Raspberry Pi with its uncompressed kernel. Okay, so that experiment didn't work, but I now have a broken Rock Pro 64. Right. Still strange that this version won't boot it though. I've got to say, this is outside of, I don't know much about this stuff. I don't know why, I don't know where the actual problem is, but I'm going to power cycle the Rock Pro 64 so I can also network boot that as well and fix it. So you see, this is a U-boot version from 2023 that lives in the SPI flash of the Rock Pro 64. And actually, in case you're wondering, those of you who have a Rock Pro 64 with Slackware on it, I have no plans to upgrade the version of U-boot on here at all, because the newer versions don't work as well. They tend to hang and the machine won't boot at a certain... Yeah, there's a lot that goes into testing bootloaders. Sometimes they work like 9 times out of 10, and that's not good enough. It needs to work 10 times out of 10. And this is the version that's been stable for a long time. And once it works, it's great. Just leave it. There's no reason to change it. Okay, so what I'm going to do here is, is do the same thing. So I'm going to, I've got my script here, and what are we looking for? The ROT Pro 64. So I'm just going to type these. Sometimes you can paste these in, but you'll probably see, if I do, oh, it works here. Yeah, that's something I don't understand either. So I'm just going to fix that. In the really old versions of U-Boot, you could copy, lines of text that were, I don't know, well over 100 characters in length, and you just pasted it in and it worked. And then with newer versions of U-Boot, it stopped working. I've got no idea why. Does that work? What the? What? Oh, okay, there's something in there that saves the SPI flash config. That's fine. Don't mind. Okay. Don't know why I've got that in there. That's a weird thing. Why have I got that in there? Why does it save? Hold on a minute. Why does it do that? Build. Where's the ROT Pro 64 script? What does it do? So this is the script. It's a bit too big, isn't it? You can't even read it. This is the script that actually builds those things. Netboot PBS. Where does it save? Oh, save env. Oh, it just saves the environment. But okay, yeah, fine. That's fine. Okay. Oh, wait a minute. Is that because? Oh, boot I. Because that's the but then I can't change it. Okay, I was just thinking because there is I've just remembered in U-Boot there are different versions of the boot command, and I think there was one like boot Z or something like that. Tell you what, let me just fix this first. Let me have a look at that in case that's what it is. /Q. So in this case, it's the ROT Pro 64, and it boots off of the SD card as well. Is that right? I forgot how it does now. Yeah. It's this one, isn't it? So if I do mount /Q, we'll soon see. Yeah. So here's our gunzip DC image. Okay, so we've got our 33 megs file back. Sync that up. Just see if that reboots properly. Hopefully this boots into the OS this time. Okay. So yeah, developing open source, there's a lot of sitting around waiting for things. I'll tell you, back in the old days with the 32-bit machines, it's just so slow, like you wouldn't believe. I mean, even just for example, unpacking a kernel source on the 32-bit machines, it's just, you'd sit there waiting for minutes and minutes, and then I think, well, what else am I going to do? Am I just going to sit here watching this thing, or should I go and do something else in my life? And I think, well, if I go and do something else with my life, then I'll forget about what I was doing. So then in the end, I'd probably just sit there, or I'll do it while I was busy doing something else on a different screen. But then I'd just kind of like be splitting my mind between two different things, and that just wasn't particularly helpful. So now everything's so fast since Brent got the added the support for the Honeycomb LX2, and now it's almost instant. You just type something in and it's almost done. The commands respond almost instantaneously. It's amazing. It's this machine's. I just love this machine. The Honeycomb LX2. Okay, so you can see that the ROT Pro 64 is booting again with its with the uncompressed kernel. So I just wonder though whether Z-image, can you boot an Z-image on a, is it by any chance that if I, Yes, I'm still confused. Why? So clear. I mean, when I compressed it, it clearly booted the kernel. It just couldn't find um, the the root file system. Which, I mean, okay, yeah, we can look into that. But I wonder. You know what I might do actually? Oh, but then no, there's no point. The problem is, I was going to say, I could see if even if I can get it working on the Rock Pro 64, it doesn't boot on the Raspberry Pi, and because this is a where's Honey gone? Because this is a generic kernel. I mean, we've got one kernel, this one, for all machines. So this one now the compressed package weighs in at 66 megs. Because we have a single kernel, it has to work across all of the hardware models. So even though it works on Honey, using Grub, if it doesn't work on because it's a generic kernel, generic package, it just has to work on every hardware model. So if the only way to make it work is by having an uncompressed kernel, then that's obviously what I need to do. But I am kind of still curious though. I'll tell you what I'm going to do. Develop ARM Slackware A kernel ARM. Right, so if I just so that's the Raspberry Pi. I forgot about that. Damn. HD develop ARM Slackware A braid kernel ARM 8. So I'm just upgrading the .4 kernel to the latest .8. And this will drop me this will deploy a kernel that's uncompressed. Because obviously you saw me compress it manually. So the reason I'm doing this is because I'm just wondering whether it was something to do with the size of the initial RAM disk. I'm just curious, really. So let's just do that. One of the other things I wanted to look at, earlier I was saying how much faster this machine is. If I unpack that, it's so much faster on here. I mean, it takes just a moment to unpack it. I mean, I'm unpacking it into the RAM disk, so it's even faster, but look at that. If I did this on 32-bit ARM, or even on the Rock Pro 64, I mean, so much slower than on the Honeycomb LX2. Brent, I love the Honeycomb LX2. Thank you so much for adding support for this machine. It's changed my life. Okay, so I'm just curious here. SRC unpack. What I want to do is where's the I forget where it is now. There's it's not a Z image, is it? There's I forgot where it is now. VM Linux. So if I do gzip, is the gzip. What I'm trying to do is just figure out how it actually compresses it, because I'm just wondering whether it does anything special when it compresses it. If you do make Z image, does it actually do something different other than just gzip it? Is the kernel binary executable, and as part of the execution process it has decompress code that understands that the binary it wants to load is compressed, decompresses it into RAM, and then boots the decompressed version out of RAM? Or does it just gzip it? I don't actually know what it does. Gzip. What I'm going to do though, because I don't know and I don't want to look through all the make files, I'm just going to do that and see what happens. Okay, there's absolutely nothing special whatsoever about the way that the kernel build process gzip compresses, or in fact does any other compression whatsoever. I mean, if I look, C4, if I look around it, okay, hold on, does a little bit much, less. Where is it? Well, okay, I was looking for the other compression types as well, but Yeah, they're all the same. Yeah, there's nothing different. Okay, so let's just do that again. Yeah, basically I just thought perhaps there was something more complicated going on, and there isn't. It literally just calls gzip with -9, which is the best compression, or the tightest compression, and then just dumps it into a temporary file and renames it. That's it. So that's exactly what I did manually. So there's nothing special there. There's nothing to fix or anything I can test. Okay, fine. Well, at least I looked. Okay, that's already reinstalled. Is it? Oh yeah. So here we go. So I'm just going to. So this is the Rock Pro 64. Just upgraded to the latest kernel. Slash boot. The reason this is all going weird is because I'm doing it over the serial console. Right, so you can see I've got my 33 megs kernel there, so that's uncompressed. Let's just make sure, rather let's just see if this machine, just to make sure we can still boot this new kernel. Hopefully we can. Is this the moment where I think I could add some music to these YouTube videos? But you know, the thing is, I don't like, when I watch YouTube videos, I don't like that there's music there. Do you guys like when there's background music? I mean, let me know in the comments if you like background music, if you've even managed to make it this far. You know, but this is like what my life is. I mean, I'm literally sitting here looking at a screen. I'm looking at what you're looking at. And I don't want any background music. Sometimes, though, I've got to say, I do put on Whitney Houston, even though I'm not exactly a Whitney Houston fan. And obviously I won't do that now because I'll probably get the video taken down for copyright infringement or something. But sometimes I listen to Whitney Houston because she just screams, and it's like, it kind of like gets me going. It's like someone screaming in my face, and it kind of gives me a bit of momentum, you know, much needed momentum. Motivation and momentum, yeah, that's what she gives me. But yeah, I'm not going to add any, I need to have a look at that at some point. Oh no, I don't, it's fine, it's just informational. That changed with, I think, the new version of util Linux. But anyway, right, so that's Pepper. Okay, so Pepper has booted. So just out of curiosity, I'm just going to finally just see gzip, just see what happens, gzip-9v, like that, just curious to know. And then let's rename this back again. Okay, let's see. Oh, actually I could have just done that one. Comma. Okay. So now we've got our 11 megs file. Just see what happens. Sync, reboot. Oh, come on. Reboot. I'm sure it won't work. Oh, I could have put the Slack PBS variable in there. Oops. Oh well, it doesn't matter. I'm not going to do much more, I don't think, if this doesn't work. I'll just fix it so that the machine boots next time. Okay. I'm actually just going to press return. Okay, I'm not going to type 1. Okay. So this is... Yeah, okay. Yeah, so it doesn't like... So the kernel, as you can see, the kernel boots, but it can't, it's not loading the initial RAM disk. So, yeah. Okay, fine. So what I'm going to have to do there is just power cycle it. Just quickly pull the plug out. There we go. And then I'll network boot it again and fix it, uncompress that kernel. Trying to think if there's anything else I can test. Unless there's something in the Linux config, but I might have a look at that in a minute once I've fixed this actually. I just need the installer TFTP. How to use. Oh yeah, this is the Rock Pro 64, so I think I can possibly just paste that in actually. I wonder how far I can get. Can I paste the whole? Oh yeah, look at that. That's what we like to see. Less typing. There we go. So boot the Slackware installer, and then just uncompress that and reboot it. In the meantime, yeah, let me. Where's the U-boot platform? Artboot src sources. Where's the U-boot source? Oh, there it is. QXF U-boot 2024. Sorry, is it U-boot? Yeah, U-boot. Okay. Oh yeah, this takes longer, by the way, because it's writing it over NFS. I probably could have extracted that to the RAM disk. That would have been, or even just local storage on the SSD. Actually, that would have been faster. U-boot's quite large with many small files. Okay, so /fdisk-l mount the boot partition /q clue g. Oops, no, that isn't it. What is that? Oh yeah, whoops, it's not that one, it's the other one. Mount, it's actually number 1, g unzip-dc image fv, goodness me, fv image, that sync reboot. Goodness me, I'm typing too fast. Right, there we go. Okay, so what I'm interested in here, iname, let's just see if this actually boots on the back. Let's observe that. Iname, I should slow down typing, I think. X Linux. Let's just make sure that boots. Hopefully it does. I'm sure it will, given that that's the only thing I changed. Okay, yeah, it should be fine. Cool, cool. Okay, so yeah, what I'm kind of interested, yeah, that's fine. So what I'm interested in here, what is this? This is, I wouldn't have seen that before. What is that? Kernel, blah, 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 blah. Yeah, there's nothing. What I'm just trying to see here is are there any, is that one? Yeah. Is there anything at all to do with compression? Do you have to set anything? I don't think so, given that the Rock Pro 64 clearly booted it, or rather it was booted on the Rock Pro 64. What is that? I don't think so. Yeah, okay. What's that? Boot lock device. Didn't know people at Google worked on that. Yeah, don't know. Okay, I'm not going to spend any more time looking at that. Well, tell you what I will do though, just to finish this off, I'll show you that it actually works on the I'll show you that it actually works on the honeycomb. So this is the honeycomb. I'm logged in over the serial port. So boot, you can see I've got my 11 megs kernel. Reboot, you'll see it boots. So it makes me wonder whether, kind of, you know, actually after seeing Grub, I'm kind of thinking, oh, actually, I wouldn't mind having Grub on the, I wouldn't mind switching to Grub actually on the other machines as well. Because, you know, I mean, well, Slackware x86 has switched to Grub now. I think it's mostly to do with secure boot. And well, I think also eLilo doesn't work on newer 64-bit machines, I think. I can't remember. But I mean, just the fact that I can select the options using cursor keys, which I love. I've always loved these types of menus. I mean, I used to play with this stuff on BBC Micros back in the 90s. You know, and then I can edit the boot configuration with it, you know, within the bootloader itself temporarily, and then boot it. I mean, you know, to me that is incredibly useful, and so I really wouldn't mind. How do you actually boot it? Control it. Oh, there we go. There, yeah. So you know, I wouldn't mind switching to Grub entirely. Actually, Brent, if you're listening, we need to investigate that. The only thing is, though, is that if I did that, it would be quite difficult to migrate. It would be quite a movement to migrate the bootloader on these machines. Or would it really? Would it? Would it really? Yeah, of course it would. Yeah. No, I can't because it's in the SPI flash. No, that'd be way too much work. It's not worth it. No, it's not worth it at all. But anyway, you can see that it's booted. Yeah, I was thinking, because, yeah, it sounds easy, but actually it wouldn't be, because the whole thing is that the bootloader is in the SPI flash of the Rockpro 64, the Pinebook Pro, and whatever else it is that we support. So it's actually, that bootloader is in there and it's tested and it works, and it's not worth it. Oh well, anyway, the experiment, it works with Grub on here, but it doesn't work for anything else. I suppose what I could do is I could make an option to, no, I'm not, I was going to say I could make an option when you install the package that it compresses your kernel, but honestly, what's the point? It's just extra work, for development work for me, for no gain whatsoever, when it takes like an extra 2 seconds to load 20 megs, or not even 2 seconds in some cases. It depends how fast your SD card is. But it takes like an extra half a second to load 20 megs extra, you know, what's the point in that? Well, I hope you've enjoyed this episode, and thanks for listening, and I'll see you in the next one. Take care. Bye-bye.